morning. Welcome, everybody. My name is Vladimir Bahyl, and today I'm going to speak about how CERN leverages tape in running the active archive of the physics data. I've been responsible for tape storage for the past 15 years, so I kind of know pretty much all kinds of details. The data flow is the following. Data is coming from the detectors at roughly 40 gigabytes per second. Then it is stored on this EOS big disk system, where it is analyzed by local batch farm. At the same time, data is stored on tape and distributed to the participating centers around the world. Let's now have a look at CERN tape archive architecture. This is basically a smaller instance of the EOS. It's basically using the same software as a namespace and disk pool manager. However, it is, instead of using spinning disks, it's using the SSDs. So while the big EOS with the spinning disk is capacity oriented and the bandwidth is a byproduct, the SSD-based CTA instance, CERN tape archive instance, is really throughput oriented, and there is essentially zero capacity because all files are just transitioning through this instance. Now I'm going to speak about the technology, the tape technology itself that we are using. And here I want to emphasize that CERN has been using tape since the last millennium, and we understand it very well, and it's been strategic ever since for us. Looking now really deep at the tape infrastructure, what we have, it's obviously dominated by the archive of the physics data, where we have provision capacity of over 500 petabytes. It is using 5 libraries for now from 2 different vendors, and we are using both available tape enterprise and LTO technologies available. Smaller installation to this is a backup of the business data. There we have license capacity of 15 petabytes. It is using basically the same libraries, but in partitions, just partitions of the existing libraries. And it is also using the both available enterprise and LTO technologies, just a little bit older generation. Now coming back to CERN, so what is the outlook for our archive? And this is a chart from one of the experiments, in particular Atlas experiment, where they discuss that the disk storage needs based on their 2017 computing model. You can see the blue dots for the high luminosity increase of the LHC, upgrade of the LHC, it just explodes exponentially. So because it is significant effort to change the software model, they are using different ways how they could mitigate this huge gap between disk resources and the budget available, which is basically flat. So obviously one of the prime targets is to use tape more actively for various I/O intensive workflows. What does it mean for our archive? For the next 3 to 4 years, we are expecting 180 petabytes per year at roughly 40 gigabytes per second. We are now at half an exabyte. This will go quickly to 1 exabyte. And then it will, what you just saw from the Atlas experiment, the size will just grow exponentially. So in summary, as I said, tape is strategic for CERN, and it is because it's right now the best currently available archive storage device in terms of cost, reliability, and stability of long-term periods. CERN is investing in tape for the current run, LHC run 3, but also for a high luminosity LHC up to 2030. Storage needs are growing, but the budgets are kind of flat. Okay, so we need to look for these solutions, and data retrieval never stops. It's already exceeding 1 exabyte per year. So we are definitely going to use tape more at CERN, and we are going to implement new tape workflows.